Hello, we're almost done on the videos. We've got to A6, responses of the endocrine system. So that leaves us A7, which is energy systems, and then the responses of the body to a single bout of exercise is done. So in today's tutorial, we're looking at the names of the hormones that have a big impact on our ability to exercise and recover. We are looking at what the hormone does to the body, so the effect of that hormone on the body. And then we're looking at why the body releases it. So what's the point of it? Is there a benefit and what is it? If it's not a benefit, what is the impact? So first let's look at adrenaline. It's released by the adrenal glands which sit above the kidneys, and it's our fight or flight response that we've mentioned before to prepare the body for protection and movement. So what does adrenaline do? It increases heart rate and breathing rate, and quite often I've seen in exam questions that they will give you that answer because it's a nice answer and the easiest answer, and they will expect you to come up with the rest of them, so bear that in mind. It relaxes the bronchioles. So the bronchioles were the, if these are your lungs here, so this is your trachea, your bronchi, if you remember that, where it splits into two, and then your bronchioles are the smaller air tracts, if you like, before you get to the alveoli. It initiates vasoconstriction and vasodilation. So let me refresh your memories there, with vasoconstriction being when a blood vessel or artery reduces in diameter, and vasodilation when it gets greater in diameter. We have increased metabolism, and that means the way the cell works, how quickly the cell actually works, and we're looking at working muscle cells here predominantly, and this is also able to happen because there is increased conversion of glycogen to glucose. Let me talk to you very quickly about glycogen and glucose, and this is how I would imagine it. They're both energy, they're both in the body, they're both used by the body, they're both molecules. Glycogen is what I would like to think of as a very highly concentrated gel. So do you know when you do endurance events you would take gel packs with you, and some of you might have sampled them. They're like warm snot when you've been running with them for a bit. They're absolutely revolting, but they have a high level of energy within them. So they're very concentrated, like drinking squash before you've added water. Glucose is in the blood and is also a sugar molecule within it, but it's not as dense. It's more fluid. So this is stored energy, and we store this in the liver and in the muscles, whereas the glucose is in the bloodstream. And then finally, we have got that it dilates the pupils. So this is what I would like you to have a go at if you haven't done this in class so far. If you have done it in class, maybe you could do it again as a recap. There's nothing wrong with reinforcing the work that you've done. So we will discuss it together afterwards, or you can send the work to me and I can give you feedback if you're doing this online or from home. So we've got the hormone adrenaline. I have got the effects of the hormone, so what happens, and we've just gone through all of those. What I would like you to do is fill in these gaps here and tell me the benefit or the impact. So why is there increased heart rate? Why is it useful to us when we're about to embark on some exercise? Why is increased breathing rate useful? Why is vasodilation and vasoconstriction useful, and so on and so forth. If you pause this video and complete that, the next slide will give you the answers. So here are the answers to that. We've got increased heart rate, so the increased blood flow, meaning more nutrients, in this case glucose, and oxygen can be delivered to the working muscles, and don't forget it's also to remove CO2 to keep us being able to exercise for endured or prolonged periods. The answer is the same for increased breathing rate, because if you think about it, if we're pumping the blood around the body at a faster rate, we need to make available more oxygen for that blood. And if our breathing rate doesn't increase, we're going to limit the amount of oxygen we can get in there. So they both have to work together. Initiating vasodilation and constriction. Well, the benefit to this, or the reason it happens, the impact, it constricts the blood to the gut because we're no longer needing to digest food. Our priority is now exercising, so it dilates the vessels working towards the skeletal muscle. And again, the benefit there is increased nutrients, glucose, and oxygen delivery and CO2 removal. The next effect of this hormone adrenaline was to increase metabolism, so working of the cells, and we're talking about skeletal muscle here and muscle contractions. So it increases blood glucose levels because the liver is stimulated to break down that stored glycogen and put it into the blood as glucose. And therefore we're able to make more energy in our mitochondria, a new word for you, in the muscle cells. So the mitochondria are the powerhouse of the cell. It's where all this ATP is resynthesized in there, and we use glucose to do that. So we're breaking down more glucose for the muscle cells so we can have contraction. We learn all about that in section A7 next. The last one is that it dilates pupils. Now, this is on the mark scheme, it was allowed on the mark scheme, but there was a comment by the examiner when a student answered this that it wasn't the answer they were expecting. It is in your textbooks. So perhaps we would think of this as an extra one, and the others being more important. So what the dilation of pupils means is that it increases the amount of light that can go into your eye. So vision is enhanced, and if you've got enhanced vision, you can have quicker and probably more accurate responses. So let's move on to cortisol then. This is often known as the stress hormone, but actually does work hand in hand with adrenaline. It's released as an emotional response to a stress or a perceived threat. And that could be, again, someone said to you, right, you're about to go on, get warmed up, we're subbing so-and-so and you're going to take their place. That can be a perceived threat. Right, I've got to get ready to perform. And this will be an immediate response of the body to release this cortisol. So it helps us, as I've mentioned there, get ready for exercise, similar to that of adrenaline. Now, there is a lot of bad press about cortisol that you will read. You will see Bradley Wiggins' name come up against cortisol. You can see here Andy Murray. This always causes debate because it's the question as whether it is a cheat or not to artificially use cortisol or cortisone. They're not identical substances, but this cortisone is a substance that mimics cortisol and can be used additionally for athletes to sometimes give them an advantage. But as you can see here, it combats the stress. It suppresses inflammation. So if you think about the joints, inflammation of joints on elite athletes that are training all the time, if they can suppress this inflammation, they're going to be able to perform for longer, train for longer. It helps release energy for the fight or flight, so certainly at the beginning of exercise it would give them a benefit, possibly an advantage, and it's widely used, as you can see here, in the treatment of asthma and injury. Now look, our exam doesn't go in to discuss whether it should be or shouldn't be used and what this artificial cortisone is, but I just thought it would be interesting for you to see the links there because you would have probably heard of it. So cortisol, what does it do? It increases the release of blood glucose. It regulates energy for the body. So we've always got that glucose to make muscle contraction. So that energy we're talking about is within the skeletal muscle. Therefore, there is increased available energy for muscle contraction. And therefore, our body can function effectively in the sport that we take part in. However, cortisol also has bad press in terms of regular stress. So if the body is put under regular stress all the time, and examples of this could be sleep deprivation, excess caffeine and alcohol, But it can be job stresses, it can be overworking. So you're going to school, then you might be doing homework, and then you might be going out to work, and then you might be gaming till late at night. So that sleep deprivation, that inability to turn off, can release excess cortisol or regular cortisol, and that's when we start to have a problem. Why is it a problem? So we need to look now at why too much glucose in the blood system is an issue. Why it suppresses the immune system, that would lead us more open to viruses and bacteria such as colds and flu. It reduces the absorption of amino acids. Now, amino acids are a posh word for proteins, or they're the elements that make up proteins. And we now know that these proteins are the building blocks of skeletal muscle themselves. So if we are not absorbing amino acids from our foods, we cannot then be healing our skeletal muscle very well. It reduces calcium absorption also, which we immediately think of the bone. So can you do the same practice on here? Complete the table for me by putting the impact, if you think it might be negative, or the benefit to having too much glucose, reduced immune system, absorption, or sorry, I should say decreased absorption of amino acids, and decreased calcium absorption. If you pause the video, and then the answers will be next. So here are the answers. The answer to too much glucose in the blood and what's the impact, and it's certainly negative, is it wreaks havoc on the body. I mean, in serious situations, it can lead to diabetes, high blood pressure, as it affects and causes vasoconstriction of the arteries, and it can prevent insulin from working. And insulin is such an important hormone for us to regulate blood sugar. You can read pages and pages on the ill effects of too much cortisol in the body here. We will not be asked in detail for any of this box in our exam question. So it reduces the immune system. This is really important to training, because the more prone we are to illness, like viruses and bacteria, the less likely we are to be able to train or train to our potential, so it will have a big impact on our performance. Decreased absorption of amino acids means we're going to decrease our muscle mass. So that's a good key term to start using. If we've got reduced muscle mass, then the likelihood is that we get more likely to be injured when we come into a tackle, or when we've jumped for a rebound and landed. We can tear muscles, we can tear our tendons and our skeletal muscle. So it's really important that we can absorb these amino acids from our diet. If we do get an injury, even if we are absorbing amino acids, we could normally repair them fairly quickly as well. But if there is depleted absorption of amino acids, it means that our repair and recovery will not be as good. So the impact of that is that maybe you can't train every day. Maybe you can't even train every other day, because you have a training session, then you're out for 3 days because you ache so much. Finally, we've got decreased calcium absorption, which I linked to bones in the previous slide. And here we've got reduction in bone density. There's our key term, bone density. If we're decreasing bone density, then it means we have increased the likelihood of a fracture for high impact activity. Same examples, so tackling. It could be jumping for the rebound, but it could also be going in for a tackle. So you've got body contact there. It could be running. If the bone density is really reduced, then even impact activities like running can cause fractures, stress fractures of the bone, which means you can't train, which means you can't perform as well. So testosterone. Now, we will have watched this video in lesson and had a look at the athletes that have been caught doping. Don't get me started on Lance Armstrong again. But there is plenty to write about. I think Arnold Schwarzenegger has also wasn't on the list. He's also at some point been or admitted to taking testosterone. So why? Why do they do it? First of all, it's the primary sex hormone. It's higher in men than ladies, although present in both genders. And it may be, this might be something you're interested in, but there's a lot of There's a lot of articles about Caster Semenya, the athlete, very fast runner, who was actually banned for competing as a woman despite having female chromosomes. Really interesting about levels of testosterone, and now it started a big discussion about how there should be a top level of testosterone that you're allowed to compete as a woman. Again, it's really interesting to read and will develop your knowledge. So have a look through some articles. I have put some on OneNote for you to have a read through. But our exam does not focus on this particularly. It does focus on the fact that testosterone encourages muscle tissue growth. We're talking about those skeletal muscles. Again, we need to make those skeletal muscles bigger and stronger to withstand force. And the process of that is through protein synthesis. Synthesis means to make. Protein, as we know, are what makes up muscle fibres. Those actin and myosin, you may have done those in Unit 2. They're all proteins. It increases our levels of HGH, which we're coming on to next, and it increases the amount of neurotransmitters the body have, another important word. So what on earth are neurotransmitters? Right, neurotransmitters are chemicals responsible for passing the electrical signals from the CNS to the muscle fibres. So do you remember that motor unit we would have done in lesson time? So we had the dendrite, or I would have called you, just said to you, I think it's the CNS, the central nervous system. And we have a nerve, which we call the motor neuron, coming down to these muscle fibres. And we've got these nerves spreading out like little hands. Now on each join here, the neurotransmitter allows this nervous impulse, this electrical signal, to be put across into the actual muscle fibre. The neurotransmitter allows that to happen. Without neurotransmitters, it cannot happen at all. So as you can see here, very important, no neurotransmitters, no muscle contractions. So if you think about it, if we've got more neurotransmitters, we can get more contractions. If we can get more contractions, or we can get more messages, more frequency going to those muscle fibres, we can get more powerful contractions. So the strength and the speed of our contractions can be increased, which will have a massive impact on our performance in sport. So they are really important. You may have heard of a couple of neurotransmitters. I put a couple of examples in there for you of dopamine and serotonin. Again, great reading around on these hormones and the feelings that they give you, and it will tell you a lot about the benefits of exercise. So human growth hormone, again, we would have watched this video in lesson. Look it up or pop into YouTube, Lionel Messi, HGH, where he had a course or a series of HGH when he was younger. And without that, he would never have become the footballer he was. Now, it wasn't a performance-enhancing drug in the sense that he didn't have to do any work to become a great footballer. He did. But what would have happened had he not had them is that he would have had very stunted growth. So this hormone is released by the pituitary gland in the brain, and it stimulates growth and repair of bone. It stimulates growth and repair of cartilage. It boosts protein synthesis, so we're talking about increased muscle mass again to make that person stronger and withstand forces better and not get injured and be more powerful. It boosts fat metabolism as well. Well, no one wants fat mass in their body. It's of no use to us particularly. It's just extra weight, and it can cause mobility issues, so it can affect our technique and things like that as well. So human growth hormone decreases the fat mass as well as increasing muscle mass. Sounds wonderful, doesn't it? And again, a lot of people take it. Lance Armstrong, along with many other drugs, took this to cheat with his cycling. But you'll find a whole list if you have a look on Google of people that have taken it, and you can read around it. It's so interesting. So estrogen is our final hormone. It's the female sex hormone, and the job of this is to regulate bone remodelling. So if you remember, remodelling was the simultaneous formation and resorption of bone, the simultaneous actions of the osteoclasts and the osteoblasts. So we would have had the osteoclasts breaking down the bone and the osteoblasts forming the new bone. So we needed this remodelling to be, or you need it to be regulated, so your bone density remains the same, it's maintained, it stays strong. So it regulates this osteoclast activity and inhibits the bone reabsorption. So it inhibits all bone or too much bone being reabsorbed and being broken down, essentially. Now then, more doom and gloom for us middle agers. This was, and we have talked about this in the first section. We talked about an imbalance in the remodelling process. So when you are older, estrogen decreases the amount of estrogen that you have. So there is now an imbalance in the making and the breaking of bone, in the clasts and the blast activity. Osteoclasts end up lasting longer, which means that they clear away more of the old bone because they're there longer. This then decreases the bone density, which means the impact of this is that we're more likely to get injured, because we now, if we're doing high impact moderate activities, then the force put on our bones is not able to be absorbed. So you could possibly get hairline fractures, things like that. You could get big breaks from it. It could be very painful. So we need to counteract it at middle age, and that is done by stimulating osteoblast activity and suppressing osteoclast activity. So slowing that down, but stimulating osteoblast activity, the laying down of the new osteocytes to build more bone. And we do this with weight-bearing activity. So we would have discussed in lesson as well the suitability of this. So if you've got a much older person that isn't used to exercise, you would give them weight-bearing activity but of a low impact, such as walking. If you could give them light weightlifting as well. If somebody is used to exercise but is still suffering with a reduction in bone density, then you could give them jogging to do, you could give plyometrics if they have the muscle strength and a basic level of fitness, essentially. If there is a big reduction in bone density due to the reduction in estrogen being released, we call this osteoporosis. And that's it for section A6.